Today in this video we are going to see about the working principle and characteristics of MOSFET. So before going to our topic, just we'll recall what these few basics. So semiconductor is nothing but a combination of N-type and P-type material. The most common form of diode is PN junction diode, where it will works very good in the forward biasing and there will be no current flow in case of reverse biasing. So FET is nothing but a field effect transistor. The basic idea of using FET is nothing but the voltage control device and the channel conduction. So moving into our topic. So today we will be discussing about the construction and working of MOSFET, its operation range and its characteristics, what are the advantages and the applications. We will see one by one. So before going deep into our topic, why we are going for MOSFET. So expansion of MOSFET is nothing but the metal oxide semiconductor field effect transistor. So it is most mainly used in the modern electronics. Why it is being used is that the legacy background bottleneck of using the BJT and JFETs are due to its critical limitations. They are high power consumption, which is not suitable for dense integrated circuits. Gate leakages were there in case of JFETs, so current loss will be there, and the limited scalability, which was a very extreme barrier for VLSI miniaturization. So in order for a modern electronics demand, it requires exactly the opposite format of which is being used in BJT and JFET. Here comes our hero MOSFET, which overcome these advantages. So as I said earlier, MOSFET is nothing but a metal oxide semiconductor field effect transistor. So it is used mainly for switching and amplification of signals. It is a voltage control device, and there will be a great voltage control across the current flow between the terminals. Okay. So it has a 3 terminal: gate, source, drain. So gate is nothing but our common gate. It controls the channel formation via electric field through oxide, and source is nothing but the origination of the majority carriers, which is defined as a reference potential, and drain is nothing but the destination of the majority carriers. It will start from the source and it will go towards the drain. In drain part only will be collecting the currents. So it has a bulk body, which is a semiconductor body, which is often connected to the source. So this is a simple anatomy of layer by layer breakdown of the MOSFET. First we have substrate. It can be of P-type or N-type. Based on that particular substrate, it will behave as a N-type MOSFET or P-type MOSFET. After that we have a source and drain, which is heavily doped with N plus or P plus. It serves as an entry point and exit point for the charger carriers. Next is gate oxide, and next one is the gate terminal. The gate terminal is nothing but a metal or silicon electrode sitting on the top of the oxide, acting as a plate of capacitors. So in the through the channel, the vital conduction of path is directed beneath the gate oxide between the source and the drain. Next comes are the types of MOSFET. We have two types of MOSFET: enhanced and depletion layer. Both has P-type and P channel and N channel. For enhancement mode has P channel and N channel, and again depletion also has P channel N channel. So in this enhancement mode, which is normally in off state, which is highly preferable for switching and digital logic circuits to save power. So physically no channel will be there by default. So the channel must be induced by applying the gate voltage in order to make it exceed the specific threshold. In case of depletion mode, it is normally on. So the gate voltage is applied to deplete the channel and reduce the conductivity. The conducting channel is pre-dropped during the manufacture and the current flow without any gate voltage. So coming to the working of the MOSFET, the MOSFET works with following steps. First we will be applying the gate voltage. After applying the gate voltage to the MOSFET, an electric field is being generated. After that, for the formation of electric field makes the channel conductive between source and the drain. Once the conducting channel is being established, the electric field forms the current flow starts from the channel to the source through the channel which is being formed. Removing the gate voltage will stop the current flow between the source and the drain. So the working of enhancement mode MOSFET, we are considering the N channel now. So when the gate voltage is 0, no biasing is being applied. So source and drain both will be of N plus in the P subtract 1. So no conduction path will be there. So device is being in cut off. So the drain current value will be 0. The next comes are the depletion phase, where the gate source current will be from 0 to V threshold value. In this, positive gate voltage repels the holes from the B substrate which is near the oxide. The depletion layer forms below the gate. So inversion it, but still the device will be only in cutoff region as it is repelling the process. So no channel will be formed. When the gate voltage is equal to threshold voltage, then the surface potential is large to attract the electrons from N plus, and the N-type inversion layer is formed connecting the source to drain. This is the threshold, and the channel just forms to begin. Okay, when the VGS is above the threshold voltage, which means the conducting N-type channel is now existing between source and the drain, and VDS current drives the ID from source drain to source to the channel, and the channel charge density is approximately to VGS minus VTH. Okay, so these are the 4 different value or the operation which is done using the MOSFET. So this is the physical channel inversion or the field effect. When no current is being applied, no channel is being formed, and then no conducting part exists. In the case of applying the positive voltage VGS, the metallic gate acts as a capacitor plate, and the electric field repels the positive holes downwards and attract the electron and silicon surface. When the VGS is above the threshold, then gate voltage exceeds the threshold, a continuous N-type conducting path is being formed. So we have 3 linear region of operation in MOSFET: cutoff region, linear region, and active region. So when VGS, that is our gate source voltage, is less than the threshold, then it is cutoff region. It acts like an open switch. Since our drain current is 0, then it is when it is in linear region, then the source drain voltage is constant. So the drain current rise linearly along with the VDS. In case of active region, the channel pitch of region is being there, so it becomes relatively constant and independent, independent of further increase of the VDS. This is the output characteristics of our MOSFET. Since it is an voltage controlled resistor, the ohmic region is higher when VGS is higher. VGS means the resistance is lower. Okay, so the amplification zone in the saturation region, the device acts as a constant current source. In case of pitch of boundary, the channel will linearly increase against the drain current. Coming to our advantage and disadvantages, MOSFET has high input impedance, scalability, low power, fast switching, and parallelization. In case of disadvantages, low transistance, ECED suspensions, short channel efforts, gate leakage is still there, and the sub-threshold slope is also there. Coming to the application part, MOSFET is being used in large number of applications like digital logic, power electronics, RF amplifiers, analog switches, and voltage regulators, surface interfaces, memory cells, smart power ICs, etc. On a summary, MOSFET has 2 types: enhancement and depletion. and then the working principle will be also in both enhancement mode and depletion mode. It has characteristics like output characteristics and transfer characteristics, and then the configuration, it has common source, drain and gate. So hope in this video you have understood what is meant by MOSFET, why it is needed for our modern technology, what are its type and its pros and cons and in application. Thank you.